All right, so let's look at some matrices in video games. So let's consider we have the idea of we have a forest and there's a tank which is approaching, and from it, it's trying to shoot down this drone. But the drone has a particular flight path where it's trying to get back behind the trees and escape, and the tank has to aim and try and hit it before it reaches that escape route. So if we're able to intersect at that point, then we are successful in shooting down the drone. Now, let's apply this to the fact that this is completely matrices, and we can see it a little better if we put a little grid on it. On this grid, maybe we can put some axes, some X and Y axes, as you're accustomed to. And we can see the angle to which the tank is shooting. That is a straight line. And as you know from straight lines, we can find the gradient of the line. There are formulas like y2 minus y1 over x2 minus x1. Simply, the students, a lot of them prefer if we're starting on the left and we're moving to the right, we're moving 1, 2, 3, 4 spaces to the right. And when we reach there at the right angle, we turn up, we move 1, 2 spaces up. So therefore, the rise over the run, it is 2 over 4. And from this graph that we have, the y-intercept is at that point, which is 1. So we know c is equal to 1, and the gradient is 2 over 4, or a half. So y is equal to mx plus c. M is a half, x plus 1. And we found the equation of the line. Now, similarly, let's do the same for the drone. Let's consider the drone. We want to find its gradient. So we can draw a right angle triangle. And if we start where the drone is and we move downwards, then that direction is 1, 2. It's negative 2 because we're going down. And then we're moving to the right. 1, 2, 3, 4, 5, 6 spaces. So we have the rise over the run, or the change in y, which is minus 2 over the change in x, which is 6. Right, so minus 2 over 6 is equal to 1/3, but negative 1/3. And it's cutting the y-axis. So the c value for this line that the drone is flying will be that value, 1, 2, 3, 4, 5, 6. So y is equal to minus 1/3, that's the gradient, x plus 6. And the point of intersection for it to be a successful uh, interaction will be where the two meet. And what we're going to do in this video is be able to work out or solve these two simultaneous equations, which we'll be doing using the matrix method. So remember, this channel's purpose is specifically to help students who are struggling in the areas of mathematics. And our channel has been in from 2009. It has past paper solutions from then up to the present. This video is looking at matrices, the actual explanations of solving simultaneous equations. If we look in the description down below, we will see 17 playlists in which we should be going through in order to cover the entire CSEC Maths syllabus, and there are no lessons required. Everything is covered. We also have a similar channel for additional mathematics and for primary math at the SCA level and so forth. All these are linked in the description down below. So we want to be able to work with this. So let's start with the identity. when we're using a 1 by 1 matrix. So let's recall identity matrix as we had in our first video when we were looking at this, as this is our third of 4 videos. An identity matrix, the main diagonal is 1 and the rest of it is 0 elements. So if we're looking specifically only for a 1 by 1 identity, if we have 8 books and we have Sarah here, this is a compartment for her books, right? Sarah will be represented just by, that's the only information, by 8. So she has a 1 by 1 matrix representing her needs. And the cost of books is $1. As such, when she goes to the bookstore, and that's a compartment for it, then the cost is 1. So we put it up there. We can also identify from our picture up on top that a 1 by 1 matrix, if there's 1 alone, that is the identity. So we'll call it I, the identity. So if we had our books and Sarah wanted to get to that point, then we know the total cost is 8 books at $1 each. 8 copybooks will be $8. So Sarah times SI is equal to 8. S for 8 and I is 1. So when we do the multiplication, it will be first row by first column, blue times blue, which we're doing all the time. So it's 8 times 1, which will give us 8. And what's the point of this? Since we're actually trying to cover the content here, that S times I, Sarah times the identity, gives us back S. That's how we know that's the identity. And if we reverse it, I times S, let's switch it around. I is the identity, which is 1 times Sarah, which is 8. And when we do that multiplication, let's set up the solution there. It'll be 1 times 8, and 1 times 8 works out to be 8. And the point to that is that we're going to get the same thing, that I times S is equal to S. As such, if we have a matrix S multiplied by the identity, we'll get back S. If we switch it around, we have the identity times that matrix, we will still get S. Thus, I is equal to 1 is the identity for a 1 by 1 matrix. Now, let's look at the topics in the CSEC syllabus, that we have 10 topics, and we're specifically honing in on the 9th topic. And vectors and matrices, because it's a modular paper, are tested in module 2, not in module 1. No questions in module 1 are coming on vectors and matrices. And they will have 4 questions or 4 marks for multiple choice on vectors and matrices, and 4 on the written or long paper, paper 2. And in module 3, they will have 3 questions on multiple choice for topic number 9, and 9 questions, 9 marks, for the long paper. So we, of course, we're not going to get all those marks. We're specifically looking in this here video at matrices. Let's look at the identity for 2 by 2. And we see this is developing into why it's important for us. So that some matrix K times I is equal to K. So if we consider Sarah, which has 8 books and 6 pens, and the books are $1, and the pens are free, completely free in this special offer, then when we consider we have Sarah with her 2 compartments for books and pens, then let's call that K. K is equal to a 1 row by 2 matrix, 8 by 6, if we're only considering Sarah so far. And of course, the same format. Let's get accustomed that we want to go to the store where we have books and pens. And the identity is $1 for books. And the pens are free. Therefore, if we want to move, then books and pens will come down onto the point where they're lined up. So what's the total cost? How many books do we need? We need 8 books at $1. That's $8 in copybooks. And what's the cost of the pens? 6 pens at free at $0. It's 6. It's going to give us 0, sorry. So 8 plus 0 is $8. Now let's consider if we had a second bookstore. Then in that bookstore, they had a special where the books were free and the pens were not. They were $1. Then we could put it in here so that in terms of cost, we actually have a 1001 matrix, which is an identity matrix. And that means Sarah, if she went to the second bookstore, the 8 books would be a total cost of 0. And the pens, which are 6 pens at $1 each, is $6. So she would spend a total of $6. Now, if we compare that now, remember the order for these costs or the identity is 2 rows by 2 columns. Now, let's include Liam. Liam has 5 books and 4 pens that he requires. So we could put that into K. So the first row represents Sarah's needs, and the second row represents Liam's book list or his needs. So the order would be also a 2 by 2. And what happens here, the books will cost Liam $5 if he goes to the first bookstore, and 4 pens, which are free, will be 0. So it'll be a total cost of 5. While if Liam goes to the second bookstore, the 5 books will be free, and the 4 pens will be 4 by 1 is $4. So we're going to get a total of 4. So we have a 2 by 2 matrix multiplied by a 2 by 2. As you see, the internal numbers there are the same. So we have them circled in a green rectangle so that you can see that they work. And the answers will be a 2 by 2, 2 rows by 2 columns. So we're going to get 4 values. If we write it in matrix format, it'll be k times I. So it'll be k, which is 8, 6, 5, 4. And that will be multiplied by 1, 0, 0, 1. So it'll be multiplied by the identity for a 2 by 2 matrix. And when it's k times I, let's pull it out so we could see it easier. Then what are we going to multiply? The first row by the first column. So blue times blue, 8 times 1. And that's going to there. And then red times red, the second row, the first row, second element by the second element, 6 by 0. And now we could multiply the first row by the second column. So that will give us our top right side answers, 8 by 0 and 6 by 1. And now we need to work out for Liam's books and pens. So we're going to look at Liam in the second row, and he's going to the first bookstore. So books will be 5 by 1, which is $5 in the first bookstore, and 4 free books, which is 4 by 0, which is 4. And then Liam in the second one, in the second bookstore will be 5 free books, 5 by 0, and 4 pens at $1 each, which is 4. So now we can simply summarize. So 8 ones now, that will give us 8. And then we have 6 zeros, which is 0. 8 zeros or 8 free ones, 8 free books are 0. And 6 pence at $1 is $6. 5 at 1 for Liam is 5. And 4 free pens, that will be 0. And 5 free books if you go to the second bookstore, and 4 pens at $1. So this is to give us practice and help us to be able to get that, because this is not a standard way of multiplying, and that's why many students get a lot of problems with it. But it's pretty easy when you get the hang of it. So we're going through a lot of these. So 8, 6, 5 and 0 is 5, 0 and 4 is 4. And if we look at that, that is actually what k is. K is the same. So what we learned is that k times the identity I is equal to k. So as such, anytime we have any matrix, when you multiply it by another and you get back itself, that means that's the identity. So the identity for a 2 by 2 matrix is 1, 0, 0, 1. What happens if we switch this around now? If we switch it around, we already know ki is equal to k. What happens if we have I times k? Now we know in terms of order, it's still a 2 by 2 for k, and it's a 2 by 2 for the identity, and the 2's on the inside match, and if they match, it means that the multiplication will work out, and the answer will be what is on the outside in yellow, a 2 by 2. So let's work this out and see what we get. So the first thing we're going to do, we're going to say the first row by the first column. First row is 1, 0 by 8, 5. So blue by blue, or the first by the first. So it's 1 by 8. And then the second term by the second term. And that will give us 0 by 5. And then we have the first row by the second column. We just did the first row by the first column. So it'll be 1 by 6. And then we have 0 times 4. And then we have 0 times 1, 0, 1, so it'll be 0 times 8, and 1 times 5. And finally, the second row by the second column, first term by first term, 0 times 6, they're in blue, second term by second term, 1 times 4, and that's 4. And now we can just solve here. 1 times 8 is 8, 0 times 5 is 0, and then we have on the next item, 1 times 6 is 6, and 0 times 4, that's 0. And we have 0 times 8 is 0, 1, 5 is 5. Using nice simple numbers for you to get a grasp of what's happening. 0 times 6 is 0, and 1 times 4 is 4. And what that will give us? That will give us 8 plus 0, and that is 8. And 6 plus 0 will give us 6. And 0 plus 5 is 5, and 0 plus 4 is 4. So that gives us k. And just as we had ki is equal to k, ik is also equal to k. So it proves that I is the identity either way. So multiplication is commutative in matrices only if one of the terms is the identity. As we proved before, if they're different, then you won't get those. Now what happens if when we multiply a term by another term, we get the identity? What does that mean? And this is the point to the simultaneous equations here. We have to set the base first. So if we had two terms, P, the first matrix, a 2 by 2, 3, 2, 4, 3, and Q, 3 minus 2 minus 4, 3. Well, we know the orders, and we know that the inside is 2 by 2, and the outside would mean we're going to get a 2 by 2 as a solution. So That is going to give us first row by first column and first term by first term in blue, plus second term by second term, which is in red, and then first row by second column, blue by blue, 3 by -2, and 2 by 3. So we're able to deal with that multiplication of the first row by each of the columns. Now we're going to take the second row now and multiply it by each of the columns. So the second row by the first column, and when we're dealing with those, it'll be first term by first term, 4 by 3, and then second term by second term, 3 by -4. And now that we've done that column, let's remove it. We're still with the second row, but we're going to take the second column now. So 4 by -2, the first term of the first row by the first term of the first column, and then the second term of the row by the second term of the column. And now we just simplify. So that is going to give us 3 3s are 9, and 2 by -4. So that is going to give us -8, and 3 by -2 is -6, and 2 3s are 6. 4 3s are 12, and 3 by -4, that's -12, 4 by -2 is -8, and 3 3s are 9. So 9 -8, that is going to give us 1. -6 plus 6 is 0. 12 minus 12 is 0. And -8 plus 9 is 1. So 1, 0, 0, 1, that is the identity. So what it says is, if we have two matrices P times Q, and it's equal to the identity, then one of those matrices is the inverse of the other one. So P is equal to Q inverse. So it's just like saying if we had -3 and we add +3 to it, they are the inverse of each other, we'll get 0. Or if we have 5 and we multiply by 1/5, we're going to get 1. So 1/5 is the inverse, multiplicative inverse of 5. So let's go back to solve the game. If we have y is equal to -1/3 x plus 6, and y is equal to half x plus 1, and they're trying to intercept at this point, let's pull it out a little bit so you can see it. Let's write the equations. Y is equal to half x plus 1. And if we, for simplicity, let's multiply everything by 2 so that we have nice whole numbers. So y will be 2y, and a half will be 2 times a half is 1x plus 2. And we can carry everything across and just leave the constant on the right side. So we have -1x plus 2y is equal to 2. It's still the same, we're just playing a little bit with it. And similarly, let's do the same for the other one. The other equation for the drone is y is equal to -1/3 x plus 6. And we want to make it whole numbers, so it's easy to work out. So we can multiply everything throughout by 3. So you get 3y is equal to -x plus 18. And of course, if we want the constant alone on one side, we could say 1x plus 3y is equal to 18. So we have two things. -1x plus 2y is equal to 2. And let's pull out the other one. 1x plus 3y is equal to 18. So of course, we have 2 and 18. We could write that as a column matrix. 2, 18, as showing the results. And what do we have there? Each of those has x and y in it. Those are the unknowns that we want to find. And let's look at the constants. What is the constant in the first equation for x? It's -1. And for y, it's +2. And for the second equation is 1x and 3y. So if we multiply it, we'll get -1x plus 2y is equal to 2. The same equation up on top. And if we multiply by the second row, by the column, 1x plus 3y is equal to 18. And let's just see it so you can see minus 1x plus 2y is 2. And 1x plus 3y is equal to 18. So now, if we know this, we want to find for x and y. So we actually have to try and get rid of that term in front of x and y, the coefficient minus 1, 2, 1, 3. So you can see because the orders are important when we're multiplying matrices, we want to put some sort of 2 by 2 matrix there that will actually be able to manipulate this. So if we use 3 and minus 1, look at what we're doing. We're taking the main diagonal, which is minus 1 and 3, and we're switching the terms. So the minus 1 comes below and the 3 goes up on top. And for the other diagonal with 2 and 1, what we're trying to is changing the signs. So it's minus 2, and then that will be followed by minus 1. So if we multiply by this matrix on the left-hand side, we have to do the same thing on the right-hand side. 3 minus 2 minus 1 minus 1. And now, let's remember that this is a 2 by 2 matrix. And we want to make sure it can work out. And they are the 2 by 2 matrix again, and the insides are 2's. So when we multiply those two matrices, the first two on the left, they should give us a 2 by 2 matrix. What about what happens when we multiply here? This is a 2 rows by 1 column, right? A 2 by 1 matrix, and that's a 2 by 2 matrix. And if we do that, we're going to get, they're able to work out because the inside is the same, and you're going to get a 2 by 1 matrix. So we're on the right track. What we're going to do is we're going to be able to find the inverse of a matrix. So let's go see if we could do that. How do you go about finding the inverse of the matrix? Let's take the exact equation we just had. And let's see if we could work out the first two terms on the left-hand side. Let's pull it out. And let's go through the multiplication. We have first row by first column as usual. So the first term by the first term is 3 by minus 1. The second term by the second term, that will be minus 2 by 1. So that's the first row by the first column. Let's now go the first row by the second column. So first item of each one of those is 3 by 2, and the second one is minus 2 by 3. So now that we have those, we're expanding it. We now have to work with the second row in the first column. And that has to multiply by each of the columns. So let's go by the first row. So first term by first term, minus 1 times minus 1. Notice you have the blues with the blues. And red by red, minus 1 by plus 1. Remember, you don't have you won't be writing this with colors when you're doing it. Normally, it's one color only. Right? So this will give you some ideas, and you have to practice. Second row by second column. So minus 1 by 2. The first of each, and then second of each, minus 1 times 3. And now we can simplify. So that is going to give us minus 3, minus 2 plus multiplied by 1 is minus 2. 3 2's are going to give us 6. And minus 2 by 3 is minus 6. Minus 1 by minus 1 is 1. And minus 1 by 1 is minus 1. Minus 1 by 2 is 2. Minus 1 by 3 is minus 3. So if we add them up, we're going to get minus 3 minus 2 is minus 5. And then we're going to get 6 minus 6 is 0. 1 minus 1 is 0. And minus 2 plus minus 3 is minus 5. So now, this looks kind of familiar. This looks like a diagonal matrix because of the fact that all the terms which are not on the main diagonal are 0. And it's a square matrix. Now, can we change this diagonal matrix into an identity? Well, let's see if we can factorize out the minus 5. We can pull out minus 5 from there. What are we left with? 1 minus 5 by 1 is minus 5. 0 minus 5 by 0 is 0. 0 again, minus 5 by 0 is 0. And 1 minus 5 by 1 is minus 5. So we really have minus 5 times the identity. So what this means is we've just worked out this in green, and that gave us what exactly? It gave us minus 5i times xy is equal to that. And we know the identity, which is 1001, multiplied by anything is itself. So we don't even have to multiply by that. So we have xy is equal to 3 minus 2 minus 1 minus 1 by 2 by 18. So if we want to solve now, there are different ways to do it. You can go and work out the terms on the right-hand side first, and then divide by minus 5 for each of the terms. That's one way to do it, and that's fine. Sometimes teachers will do this and carry the minus 5 across as multiplying. So when we divide, it'll be minus 1/5. And why? Because this is the adjacent or adjoint of the matrix, and the minus 5 that we got there is called the determinant of the matrix. So if we put them together, this gives us the inverse of the matrix we started with. So the matrix we started was minus 1, 2, 1, 3, the coefficients of x and y. This is the inverse of that. Make sure you're able to shoot down the drone. So since this is the inverse, we can solve. We can now multiply the 2 by 2 matrix by the 2 by 1 matrix. So we already have the minus 1/5 on the outside. And we're going to take 3 by 2, first of all, and then minus 2 by 18, because that's the second item by the second item. And now let's do the same thing below. The first item by the first item, minus 1 by 2, and then minus 1 by 18. So now that we have that, we are ready to solve. We can simplify. Minus 1/5 on the outside, 3 2s are 6. Minus 2 by 18 is minus 36. Minus 1 by 2 is minus 2. Minus 1 by 18 is minus 20. So that actually simplifies. Minus 1/5, 6 plus minus 36 is minus 30. Minus 2 plus 18 is minus 20. So if we multiply by minus 1/5 each, a minus multiplied by a minus becomes a positive. 1/5 of 30. What's that going to give us? That is going to give us 6. And the minuses and minuses will cancel off each other. 1/5 of 20 is 4. So what that tells us is x is equal to 6 and y is equal to 4. So if we go back now and look at this here, the point of intersection, is it those values? Let's see, 1, 2, 3, 4, 5, 6 across. So x was 6, 1, 2, 3, 4, and y is 4. So we're able to solve these simultaneous equations. Simultaneous equations with the inverse of a matrix. Let's say if we have A, B, C, D, X, Y is equal to EF. Remember, A, B will be the coefficients of X and Y in the first equation. C, D will be the coefficients of X and Y in the second equation. So it looks like this. 1 matrix A multiplied by matrix B, a 2 by 2 matrix by a 2 by 1 matrix, gives us our solution. Just now it was 2 and 18 for B. So if AX is equal to B, what we're really doing is introducing the inverse of A in front here. So we're multiplying by A inverse on the left of both equations for it to be equal. And what happens when we multiply A inverse by A? It gives us the identity. Now, let's see. Since I times x is equal to x is equal to A inverse B, then what do we know? The determinant. It was the main diagonal, AD, minus the minor diagonal, which is multiplying those two terms, BC. Right? And we did that just now, and that is what gave us the 5, well, minus 5 just now. If you go back and look at it, right? Scroll back in the video, you'll see it. And of course, the adjunct of A would be, we take in the A, B, C, D terms, and we're switching it, the main diagonal. So instead of A up there, it will be D, and A will take its place down below on the main diagonal. And on the minor diagonal, the B remains here, but it changes sign. And C remains here. If it was minus 3, it'll change sign. So X is equal to A inverse B, where A inverse is what exactly? Remember, X is XY, and B is E and F, whatever it is down there on the extreme right. So the A inverse is really 1 over determinant. Determinant was minus 5 just now in the last example, multiplied by D minus B minus CE. So XY is equal to 1 over AD minus BC multiplied by the 2 by 2 matrix D minus B minus CE by EF. So this brings us to the end of what we consider to be this simultaneous equations video. So this was the third part of matrices. There are 4 parts in all. Don't forget to add any comments down below so we can learn from what you need and create videos to help you. Don't forget to like the video as well. And in the description, please be reminded that the links to all 3 channels are there. The links to this matrices playlist, which will have all 7 videos, 4 videos of notes, and then 3 videos with 15 years past paper questions on matrices, will all be in the playlist. Our final video with regards to covering the content will be on transformations using matrices. Take care, everyone. Bye.